Take a minute and pause the video to try this warm-up problem. All right, so we were graphing one period of the function y equals 2 times the cosine of pi over 4x plus 1. So remember identifying A, B, C, and D. A is always the number out in front. B is always the number connected to X. There was nothing being added or subtracted inside the parentheses, so that means there's no C. And then the value on the outside of that function is 1, so that's D. So remember, cosine, we find the period by taking 2 pi and dividing it by the absolute value of b. When I divide pi and pi, those go away, but because I'm dividing by then technically a fourth, I really multiply by the reciprocal. So 2 times 4 is 8. So that's my period. So remember, my original 5 points would be 0, comma, a, and then a fourth of the period, 0. Half of the period, the opposite of A, 3/4 of the period, 0, and then the full period back at A. And then after we identified those, we then needed to deal with C and D. So C meant that I wasn't adding or subtracting anything onto the first numbers in the ordered pair. D meant that I was adding 1 onto the second number in the ordered pair. Notice how I've labeled my X and my Y axes. I graphed one full period. Notice because we're talking cosine, that point up at 3 on the y-axis, that's the highest point. So there needs to be curves. So make sure that you're not having that arrow point up any higher than 3. All right, so that was a nice little review there. We're going to continue with section 5.7 today. So we're going to find exact values of composite functions with inverse trig functions. So we're doing more without a calculator, but now we're going to be talking about composites. So we've done compositions in the past. Remember, compositions are when we have a function inside of another. So earlier in the year, we learned that a function was an inverse when f inverse of x equaled x and f inverse of f of x equals x. So when you put one function inside of the other and you do it both ways and you ended up just getting x, that told us that we had inverses. We're also going to use these properties to help us with the sine, cosine, and tangent functions and their inverse functions that we talked about in the other lesson that we've done with 5.7. All right, so here, these two definitions are important. So we've got sine and its inverse. Okay, so notice that we're dealing with the composition. So we have sine of inverse sine of x. It's going to equal x only when we have the interval going from -1 to +1. Okay, notice there's brackets around the intervals, which means that those numbers are included. Okay, but notice that we're dealing with having the sign out in front. Notice that when the sign is out in front, that's dealing then with the ordered pair numbers. So that's why when you're thinking about a unit circle, remember the highest and the lowest points are the radius of the circle. So -1 and +1. Notice that my second definition is that the inverse sine of sine of x is going to equal x, but that's only when x is in the interval from -pi/2 to +pi/2. The reason for that is because notice that's what is on the outside is the inverse sign. Remember, inverse means we're talking about angles. So that's why we're dealing with the -pi/2 to the +pi/2. Notice once again, there's brackets, they're being included. So that's what we were talking about in our other lesson dealing with 5.7. Okay, so let's use these two definitions here. Let's look at some examples. It says find the exact value if possible. So we are going to look at the fact that we have sine of inverse sine of -0.75. So notice that what I have on the outside is sine. So thinking back to those two definitions, that means that I want to focus on the interval with my unit circle, so the numbers, so -1 to +1. Okay, so that's the interval that I want to have this number in. If it's in, then that's perfect. If it isn't, then we've got a little bit of extra work. So the question is negative 0.75 going to fall within -1 to +1? And hopefully you're all shouting at the screen, yes, yes it is. Okay, so because it falls within the interval, guess what? That means because we're dealing with sine and inverse sine, those cancel out. So my final answer is just going to be that number. But once again, that's because I knew what interval to focus on and the number fell within it. So we're done. Okay, if I take a look at the next example, we have the inverse sine of sine of x. So notice that this time I'm dealing with the inverse sine on the outside. So let's talk about then what the interval is. When we're talking about inverse, that means we're talking about angles. So that means I want to focus on the interval going from -π/2 to +π/2. And so once I know that that's the interval I need to focus on, now I look at the angle that is given. Notice that what is given is pi. So if you're thinking about your picture, remember, 0's here, π/2 is up here, -π/2 is down here. Well, I mean, positive pi would be over here. I'm thinking about these two quadrants. Pi is not in the first and the fourth quadrant. So we have a problem. Our answer is not pi. So when you end up with something that is not within the interval, this is where we have to do a little bit of work. So when it doesn't fall in the interval, I focus on what is inside the entire parenthesis, which is the sign of pi. I actually need to evaluate this. So to evaluate this without a calculator means that, once again, if I know that pi is located over here, this is a quadrantal angle. Remember, that's the ordered pair, -1, 0. Remember, sine is the second number in the ordered pair. So that means that the sign of pi is really 0. So I am going to then be able to replace that sign of pi with the number 0. So now my problem is that I have the inverse sign at 0. Okay, 0 does fall within the interval of -π/2 to +π/2. It's just 0. Okay, so that would be my answer. Okay, now let's talk about the properties for the cosine and its inverse. So when we have cosine of inverse cosine of x to equal x, that's only when it's in the interval going from -1 to +1. Once again, when cosine is on the outside, you're thinking about your unit circle. The biggest and the smallest numbers would be -1 and +1. Notice that once again, there's brackets around it because those numbers are included. When I'm looking at the second definition, the inverse cosine of the cosine of x, it equals x, but only when we're in the interval going from 0 to pi. Once again, inverse cosine with the inverse means we're talking about angles. And so from our definition in the other 5.7 lesson, we go from 0 to pi. So we need to make sure that we know these two definitions. Let's look at some examples. So we're going to find the exact value if possible. Notice that we have cosine of inverse cosine of -1.2. So if I'm dealing with cosine being on the outside, we're thinking about the interval of -1 to +1. Okay, when I look at the number that is given to us, I'm noticing that -1.2 is not in this interval. Okay, it's smaller than -1. So just like the last problem we just did, when it's not within the interval, we have to do a little bit of extra work. So now I want to focus on what is inside of the parentheses here, which is the inverse cosine of -1.2. Okay, so I want to figure out what that is. However, -1.2, if you're thinking about what we were doing when we're trying to figure out that angle measure, we're thinking about all of our different ratios. Well, -1.2 isn't going to help us figure out what special right triangle we're dealing with. Okay, so the inverse cosine of -1.2, this is not defined. Okay, so once again, it's because we're not going to get a special right triangle. We're not going to be able to come up with a 30, 60, 90 or 45, 45, 90. And so because this particular part of my problem is not defined, neither is the whole entire problem. So we would say that the whole entire problem is not defined. All right, if we take a look at the next problem, the inverse cosine of the cosine of 2 pi over 3. So if I'm looking at what's on the outside, inverse cosine means we're talking about angles. So we're talking about the range going from 0 to pi with those being included. Okay, so we're talking about then looking at the angle that is given to us, 2 pi over 3. So if we're thinking about our picture, remember we've got 0 to pi. Well, hopefully you're okay with figuring out that 2 pi over 3, that's going to be over here somewhere. It's in the second quadrant. And so because it falls within that range, if it's in the interval, that means that the inverse cosine and the cosine cancel, and that becomes my final answer. So 2 pi over 3 is my final answer. All right, moving on to then tangent and its inverse. So tangent of inverse tangent of x is going to equal x for every real number x. So there is no restriction when you have tangent on the outside. Whatever that value of x is, that will just always be your answer. Okay, so then the second definition is that the inverse tangent of x equals x, but that's only when it's in the interval going from negative pi over 2 to positive pi over 2. Notice this time there are parentheses. So that tells me that those numbers are not included. Okay, so it's everything that's in between them, but not actually including them. All right, so let's use those definitions here. Let's find the exact value if possible. So inverse tangent is on the outside. So that means we're thinking about the interval with the angles going from negative pi over 2 to positive pi over 2, but not actually including those numbers. Okay, so if I'm thinking about pi over 8, so once again, we are dealing with 0, pi over 2 is up here at the top, negative pi over 2 is down here at the bottom. My question is pi over 8, since it's positive, will that fall in the first quadrant between 0 and pi over 2? So if you need to think about it, think about this as a denominator of 8. Okay, that's because I had to multiply the top and the bottom by 4. So technically the top is 4 pi over 8. So yeah, of course, pi over 8 is going to fall somewhere in between 0 and pi over 2. So because it falls within that interval, pi over 8 will be my final answer. If I have the inverse tangent of the tangent of 2 pi over 3, once again, the inverse tangent on the outside means we're focusing on the interval with the angles, so not including it, but negative pi over 2 to positive pi over 2. So I'm looking at the angle that is given to us, which is 2 pi over 3, and my question is, will it fall within the interval? So thinking about your picture and your unit circle, once again, 0 is there, pi over 2 is here, negative pi over 2 is here. We're trying to find it within the first and the fourth quadrant. Well, 2 pi over 3 is actually over here in the second quadrant. So right now, it does not fall in the interval. And so that means I need to take tangent of 2 pi over 3, and I need to evaluate that. So how do we do that? Well, I need to sketch a picture. Think about it. We already talked about how it needs to be in the second quadrant. Looking at the denominator is a 3. So that tells me that my reference angle is a 60-degree reference angle. So let's create the sides of a 30, 60, 90 triangle in the second quadrant. So across from the 30 would be 1, but because I moved to the left, it's negative. Across from the 60 would be the square root of 3. It's positive because it's moving up. 2 would be the hypotenuse. So If I then want the tangent of this, we're thinking then opposite over adjacent. So opposite would be the square root of 3. Adjacent would be -1. So this is -√3. Okay, so that means that now I want to be solving the problem of the inverse tangent of -√3. So this takes us back to the lesson that we did the other day. Because we're dealing with a negative ratio, we are thinking about then between the first and the fourth quadrant, we're thinking about the fourth quadrant. So I know that I want to have in the fourth quadrant, I want to figure out what that angle is. So because we're in the fourth quadrant, we're going from 0 to -π/2. That means that that angle is going to be a negative angle. All right. If we know that we're thinking about it as a ratio like over 1 and tangent is opposite over adjacent, well, opposite means that my -√3 is this leg down here. The 1 would be the adjacent side, so it's that horizontal leg. That means that we're dealing with another 30, 60, 90 triangle. Notice how, once again, the square root of 3 is across from the theta. So that means that that's going to be a 60-degree angle. It's got to be negative, and it needs to be a radian value. So that's going to be -π/3. There is my final answer. So definitely it's going to take a little bit of work for some of these problems. Other times, if it falls in the interval right away, you got an answer. Okay, so these are compositions when you're dealing with both the inverse and the original function being the same trig function. Okay, so inverse tangent and tangent, or cosine and inverse cosine. But that's not how all of the composition problems are going to be. Sometimes you're going to evaluate a composite where you have two different trig functions. So we can use points on terminal sides of angles in standard position to find exact values of expressions involving the composition of a function and a different inverse function. So an example would be something like this. We have to find the cosine of the inverse tangent of 5/12. Okay, we're not actually going to solve this particular one, but notice how we're dealing with two different trig functions. All right, so let's look at this problem here and let's talk through it. So it says we want to find the exact value of sine of inverse tangent of 3/4. All right, so when you come across these problems and their different trig functions, this time that means we're not going to start with the number or the trig function on the outside. We actually want to focus on the inside. So really, I want to focus on the parentheses of the inverse tangent of 3/4. Because we're dealing with the inverse tangent on the inside, that means I want to be thinking back to what we did the other day. Inverse means we're talking about angles. And so what is my interval? Well, -π/2 has to be less than theta, which is less than π/2. So remember, that means that we are going to be either in the first or in the fourth quadrant. Because we are dealing with a positive ratio, that's going to help us figure out what quadrant we're in. So because we're dealing with a positive 3/4, that means that we're going to sketch a picture in the first quadrant. Okay, so in the first quadrant, I want a triangle where the right angle is on the x-axis, theta is formed by the x-axis. We know that tangent, if you're thinking about SOHCAHTOA, is opposite over adjacent. So 3 is going to be across from that. 4 is going to be the horizontal leg. I can technically then find that hypotenuse. You can either do Pythagorean theorem, or you can remember that we have a triple here. It's a 3, 4, 5 family. If you couldn't remember that, you would have to do 3 squared plus 4 squared, and that would equal c squared because we're trying to find the hypotenuse. But you're going to get 5. Okay, so that whole entire parentheses of the inverse tangent of 3/4, that helped us figure out this triangle. So now that I have this triangle, I want to figure out then what the sine of theta is from this triangle. So now we focus on the outside trig function. Okay, so sine of theta is going to get me my final answer. So if I'm thinking about SOHCAHTOA, sine is opposite over hypotenuse. So opposite of theta would be 3. Hypotenuse we determined was 5, so 3/5 is my final answer. Okay. Let's take a look at another example. So let's find the exact value of cosine of inverse cosine of -1/2. So once again, we're dealing with two different trig functions, cosine and sine. But I focus on, because they're different, I focus on the inside parentheses first. So we're dealing with inverse sine. So once again, inverse means we're thinking about angles. So because it's sine, we want to have our interval go from -π/2 to +π/2, but this time those numbers are included. Okay, so remember, once again, if you're thinking about your picture, π/2 is up at the top, -π/2 is down at the bottom. So we once again are focusing on first and fourth quadrant. So I want to sketch a picture based off of then my ratio. I see that I have a negative ratio. So that means that I want to focus on drawing a triangle in the fourth quadrant. Okay, so if we're talking about then my inverse sine being -1/2, well, I want to figure out then what is that angle. Okay, so if I'm talking about my sine being opposite over hypotenuse, that means that the hypotenuse is always positive. That means that it's the one that's negative. It's across from theta. So hopefully you recognize the sides. That would have to be the square root of 3. We're dealing with a 30, 60, 90 triangle. Okay, I technically don't even care what that angle actually is at this point, because remember, when you're dealing with these two different trig functions, I really wanted to take the inside to figure out what that picture is, because now I'm going to take that picture and I'm going to figure out what the cosine of theta is, and that would get me my final answer. Okay, so if we're thinking about SOHCAHTOA, cosine is adjacent over hypotenuse. Well, adjacent would be the square root of 3. Hypotenuse is 2. So the square root of 3/2 is my answer. All right, got a couple of checkpoint problems for you. So pause the video. Notice the first one, we're dealing with the same trig function. So you're talking about the first set of examples. And then the second example here, we're dealing with two different trig functions. So you're thinking about the second set of examples we just did. All right, so in the first one, if you are dealing with the same trig function, notice that we're dealing with the outside first. The inverse sign means we were thinking about the interval of -π/2 to +π/2. 5π/6 is in the second quadrant, so that's not going to fit the first and fourth quadrants. So if it's not in the interval, I needed to go sketch my triangle in the second quadrant. Remember, that means the reference angle was π/6, which is technically a 30-degree angle. So I was able to draw my 30, 60, 90 triangle and find what the sine was. Sine is opposite over hypotenuse, so that means that sine of 5π/6 is really a half. So then I got to replace that parenthesis with a half, and now I want to know what is the inverse sine of a half. So now I'm looking back at the fact that we are in the first quadrant, okay, because that's a positive ratio. So I didn't draw it here, but we're back in the first quadrant because once again, remember, π/2 is up at the top, -π/2 is down here at the bottom. I'm thinking about sine as 1/2. Notice that because we're dealing with 1, that means that we're dealing with the smaller angle of a 30, 60, 90 triangle, because technically this side is the square root of 3. So that's why 30-degree angle, we're talking π/6. And it's a positive because it's in the first quadrant. Second checkpoint problem here, because I'm dealing with two different trig functions, I started with what was on the inside. So the inverse sine of -1/4. So remember, we're talking inverse sine is -π/2 to +π/2. Because I have a negative ratio, I know I want to be in the fourth quadrant. So I had to do a little bit of algebra to find that third missing side of the right triangle. I had to do Pythagorean theorem. That missing side was the square root of 15. Now that I have all of those sides, I'm thinking about secant. So remember, secant relates to cosine. Cosine is adjacent over hypotenuse, so I wanted hypotenuse over adjacent. 4 is the hypotenuse, square root of 15 is the adjacent. I had to rationalize it to get my final answer. Okay, so that's us finding exact values of composite functions with inverse trig functions.